Many millions of years ago, long before Salam and Lucy, Africa was a wet tropical environment covered with rainforest. This is where the ancestors of Salam and Lucy lived. They probably looked a lot like chimps. But then Africa started to gradually dry out. The rainforest began to shrink. By Salam's time, 3 to 4 million years ago, the Great Rift Valley was a mosaic of different environments. We know that from the fossils of the animals that lived here. Their bones litter the ground.
This is a canine of a hippopotamus. So this is probably a skeleton of a hippopotamus. How can one find a hippo in this type of environment? Being nice antelope.
The fossils tell the story of a vanished landscape.
This is a lower jaw of an antelope.
3 million years ago, the Rift Valley was a patchwork of grassy plains, scattered woodlands, lakes, and rivers.
Definitely very different from what we see here today. Wow, a nice pig here.
As their environment changed, scientists believe our ancestors changed too. They had been creatures who spent most of their time in trees, like chimps and orangutans today. But as their forests shrank, some of them developed the trait that we take for granted: bipedalism, walking on 2 legs. This is one of the defining characteristics of humans. But how did bipedalism develop, and why?
Bipedalism is such an unusual trait. There's no other mammal that habitually walks on 2 legs like we do.
Because it's unique, it's hard to figure out why it happened. There are a lot of theories.
One of them is that they stood up to be able to see over tall grass. Another theory, they stood up to be able to pick fruits off of the low branches of trees, the way chimpanzees do today. Another theory states that they stood up to cool more efficiently so that we don't have as much sun beating on so much of our body.
And I think the most compelling idea, the most compelling hypothesis is that it saved us energy.
And energy is crucial to survival. Let's go back to the dense forest, home to our ancient ape ancestors 10 million years ago. Like many apes today, they were perfectly suited to a life in the trees.
They're very good at climbing in trees. They're phenomenal at climbing in trees.
On the ground, these ancestral apes could probably walk on 2 legs for short distances if they had to carry something.
Fantastic climbers, but also able to walk and run rapidly and effectively, but not economically.
Walking was tiring, but they didn't have to walk far.
But if you're a chimp and you only walk 2 to 3 kilometers a day, it doesn't really mean much, right? It's not going to have that much of an effect on your energy budget.
But energy demands would change as the forest started to disappear. Our ape ancestors had to walk more.
They have to go farther to get from one fruit patch to another fruit patch, for example.
Dan Lieberman is an expert on bipedalism. He believes that walking on 2 legs evolved because it saved energy. When you compare the energy consumption of humans to chimps, there's no contest. A chimp is an energy glutton.
It spends an enormous amount of energy, about 4 times as much energy as a human walking.
Whether it walks on 4 legs or 2, a chimp can't compete with the human gait.
It's poorly designed to withstand the forces of gravity. It has to spend a lot of muscular effort to keep itself from collapsing into a little pile of chimpness or whatever with each step.
According to Lieberman, small anatomical differences created large energy savings, setting our ancestors on the path to bipedalism, a path that would eventually lead to us. But how long did it take? When Lucy's kind were first discovered, many people thought they were the so-called missing link between apes and humans. But the science of genetics has transformed our understanding with a technique called the molecular clock. Today, scientists can compare DNA from closely related species to find out how long ago they split from a common ancestor.
It's just a very simple idea that the rate of change in DNA sequences is more or less constant over time. And that's an extraordinarily powerful concept because it means that you have a way of determining when two species last shared a common ancestor.
Living forms evolve because DNA sometimes spontaneously changes as it copies itself. These changes happen at a surprisingly regular rate. By counting the differences between the genetic code of chimps and humans, we can calculate how long they've been evolving away from each other.
The dates that one almost always gets are around 5 to 7 million years ago for when humans and chimpanzees last shared a common ancestor.
Here was proof that humans diverged from the apes much earlier than we thought, about 6 million years ago. It shows Lucy and Salam weren't one step removed from chimps, but many. They may even be closer to us than to the first human ancestor. So what came before Lucy and Salam? Who was our earliest ancestor? Until the 1990s, the fossil record was blank. Fossil hunters combed East Africa's Great Rift Valley, but could only find small fragments older than 4 million years. Then, in 1997, a French anthropologist called Michel Brunet decided to look somewhere else.
We decided to go to Africa, but to the west. To the west of the Great Rift.
1,600 miles to the west, at the edge of the Sahara Desert in northern Chad.
Obviously, if you only go to the field in East Africa, then you are going to find fossils only in East Africa. This was the situation.
Michel was looking in a place where the few animal fossils he turned up were all around 6 million years old. No one expected any human-like fossils to be found in a layer that ancient.
And everyone said, no, there just aren't any fossils there.
Michel was not to be deterred. He was stubborn, many thought to the point of madness. He and his team spent years searching the desert for signs of our ancestors, and year after year, they came up empty. Then, on their 26th expedition in 2001, they found a smashed, misshapen skull around 6 million years old. They called it Sahelanthropus chidensis. There were no bones apart from the skull. Could it be a human ancestor or just another ape? The skull was so deformed, it was difficult to tell. Michel would have to reconstruct it. His first step was to take the skull, now nicknamed Toumaï, to a particle accelerator in Grenoble, France, to use its powerful X-ray scanner. Over 1,000 pictures of the fossil were taken to build a 3D image of the crushed skull. Using the virtual image, the skull could be restored to its original shape. It was then reproduced by a type of 3D printer equipped with lasers which hardened plastic. When it finally rose from its bath, the cast of Toumaï's skull was ready for detailed study. The cast allows Michel to answer an important question. Did this ancient creature walk on two legs millions of years before Lucy or Salam? It's how the skull connects to the spine that provides the vital clue. And Michel could infer that from the shape of Toumaï's skull. If Toumaï's skull is set on the neck of an ape that walks on all fours, his eyes point downward. That can't be right. Set on the upright spine of a biped, his eyes point straight ahead. For Michel, this proved Toumaï walked upright.
Anatomically speaking, he had a receding back skull of a biped. The back of his skull is not that of a gorilla, like some people are trying to say. No, not at all. All you have to do is look.
Some scientists still question whether Toumaï was really a biped. But if Michel is right, his 6-million-year-old fossil is a good candidate for the first human ancestor. Discoveries like this are changing the way we see human evolution. Scientists used to have a simple idea. The growth of open grasslands forced our ancestors out of the trees. They became bipeds, and in short order, brain size increased. Human evolution took off. We were on our way to becoming human. That simple idea prevailed for more than a century.
Darwin thought that we left the trees, walked on the ground upright, freed our hands, made tools, got big brains, reduced our canines, and so on, all at the same time.
But walking upright may not have automatically led to big brains at all. From Toumaï to Salam, both bipeds, brains stayed small. And they weren't the only ones. Over millions of years, there was a profusion of upright walkers with complicated names and chimp-sized brains. Like Auroran tuganensis.
What we're seeing is a fluorescence of species, multiple species. They're probably subtly different from each other.
Ardipithecus ramidus.
But it's important to recognize that there are not major differences among these species.
Australopithecus africanus.
They were all bipeds, big snouts, more or less chimp-sized brains.
Kenyanthropus platyops.
This way of life, this suite of adaptations, lasted for millions of years.
Small-brained bipedal apes were extremely successful. Debates rage among scientists about which one eventually led to us. But as a group, they flourished for about 25 times longer than we've been around. They survived and thrived as brain size flatlined for almost 4 million years. But that doesn't mean nothing changed. There's evidence that the seeds of our humanity were growing in these ape-like creatures. One key difference between humans and apes is the length of childhood. But what do we know about the childhood of our early ancestors?